Alright everybody, welcome to tonight. We're going to be looking at finding volumes through revolutions. So first up, we're going to start with a bound region, and we're going to talk about how to approach these problems, but then we're also going to solve basically 5 problems using the same area. So let's start off by making sure we have this area set up right. So we start with y equals x squared. Okay, so I have my parabola here. So that's my first bound. My second is the x-axis, and my third is x equals 2. Well, at x equals 2 here, it's going to run into my y equals x squared at y equals 4, and everything's starting at 0. Now everything's going to be different when you have different problems, so you got to be careful, but for this problem that's all we have. So our region that we're going to be talking about is this one. Okay, so I tried to think about what are the basic ideas you need. So the first one is what we just did, is draw the area. If you don't do that, and if you can't get that right, everything else is going to get messed up. So that's the first one. Second one is you draw the revolution. So let's now make a problem out of this, and we'll practice this step number 2 here. So trying to give you guys some strategies more than just how to solve it. So what we're going to do is in this first one is we're going to revolve it around. Let's have it revolve around the y-axis. Okay. So to revolve this thing around the y-axis, so we're going to draw a picture of what that looks like. So this is my region, and from 2 goes up to 4. And if I revolve it around the y-axis, I'm going to draw a picture of what that looks like. So I'm going to revolve it this way, and I'm going to get this over here on the left side. But I only focus on the region I start with. And what we're going to do is we're going to make that region swing around to look at it. So what we need to do first is we need to draw one of these slices. So as I revolve this around, I'm going to make a slice horizontally right here that is going to revolve around. And my task is very straightforward. I need to find an equation for that single thing. That's really what I'm going for. So let's think about how to find an equation for this. Well, the length of this black bar is really the combination of two things. The large radius right here, so I'm going to call that my large radius, and my small radius. If you notice, I have two things involved. We'll get into one where that's not the case, but we're going to do that for this one. So I have a large radius and I have a small radius. So my area for that is going to be the large radius and then dealing with the small radius. So to find the volume, I'm going to do the integral. So pi times the integral of the large radius squared minus the little radius squared, and that's going to be my major setup. Now my next job is to decide, is this a dx or a dy? In other words, are my slices in the x direction or are my slices in the y direction? So if you look here, these slices are, the thickness of them is a small y, and so we call that a dy. So for this problem, I have a dy happening. So I'm going to put a dy at the end, meaning all of the variables that I see over here need to be y's. If they're not y's, I'm doing it wrong. So let's take a crack at this. So we've already answered this one. Is it a disk or a ring? We've already done that. The next one is we need to look at our bounds. So we start at the low y value of 0 and we end at the high y value of 4. So I'm going to integrate from 0 to 4. Now we're going to start by getting my equations here. So I can't just use r. I think you know that. So we're going to get them in terms of y. So my integral is pi from 0 to 4 of my large radius squared minus my small radius squared dy. So my large radius, well, let's look what it is. My large radius is x equals 2. So my large radius is 2. That's it. Now my small radius is a little more complicated. My small radius is the equation y equals x squared. But remember, I have to have it in terms of y. So this is really x equals square root of y. So so if I think about it, my inner radius, how big is it? To simplify things, I could say, well, it's really x big, but I can't write it that way. And so instead of writing it, because it's x distance, I could just write that instead in terms of y, and that would be x equals square root of y, and so I can just plug it in here. So I get pi from 0 to 4 of 2 squared minus y dy. And this is an integral I know you guys can do. So from 0 to 4 of 4 minus y dy, and you can do that. So the point of these is going to be to really help you set them up. So let's get into the next one. So let's see if we can pick up the pace a little bit too. So here we go. We're going to do one where you go about, so it's the same area, you're going to go about x equals 2, and then we're going to do another one where you go about y equals 0. So let's start off with my area. Okay. Actually, we're going to do this right side one first. So we're going to start off with my area. Sorry, guys. And what we're going to do is we're going to revolve it around here. So this is going to be my axis that I'm going to revolve it around. And so when I revolve it, I'm going to get this. We're going to draw one of these slices. Now, if I swing it this way, my slice is going to be up and down. So the thickness of my slice is really a dx. It's going to tell me how thick my slice is here. So my integral is going to be pi times, well, my outer radius is y. So outer radius squared minus inner radius squared. Well, there is no inner radius because it comes all the way to the axis. So there's no inner radius. And this is a dx. Now, some of you purists out there are saying you can't have a y and a dx, and I totally agree. So let's get rid of that. So we cannot have y here when I have a dx. The 0 just goes away. Okay, just disappears. But what does y equal in this problem? Y equals x squared, because that's the equation right there. So what is my y? X squared. Okay. Now, do I have my terms that line up together? Yes. All right. The other thing is I need to do my bounds. Now this is in terms of x, so I start at 0 and I end at 2, so my lower bound is 0, my upper bound is 2. Okay. Now we're going to the next one, about x equals 2. This is where it gets a little more difficult. So we have our area, and I'm going to revolve it around x equals 2. So I'm going to get this here. And so I'm going to draw my slice. And they're going to be sideways slices. So is that dx or dy? Answer it in your mind right now. Say it out loud. Nobody's listening. And so this is a dy because it's a horizontal slice. The horizontal one here is dy. Vertical one was dx. Okay. And so I have pi integral, well, if it's a dy, I go from 0 all the way up to 4 of, well, there's no gap in the middle, so it's just the outer radius squared, and it's a dy. Okay, so integral of 0 to 4. This is where it gets tricky. I need to find an equation for that. Now, this is starting at 2 and going this far. So if I were to think about the length of that, this is where it's tricky. So this length right here is x. This length right here is 2. So what would the length from here to here be in all cases? It would be 2 minus x. But notice I've got dy, so I can't have x, right? So 2 minus, what does x equal? Square root of y, because y equaled x squared, so x equals square root of y. Okay? So what does that radius equal? 2 minus square root of y. And my radius is squared, so I have to have a squared here. Is this going to be a little bit more difficult to integrate? Yes, but doable. Okay? All right, now we get to the fun stuff. We're going to do 2 of these. One is about x equals 5, and the other one's about y equals 6. So try to do this on your own. Pause it, see if you can do it. Try setting it up. Welcome back. So we have our area, and here's my line, which is x equals 5. And as I rotate this around here, right, I'm going to get this hole in the middle. So I'm going to have a ring because I have a hole. Okay. I'm going to have an outer radius. I'm going to have an inner radius. The next idea is my slice. Remember, start by using your original area. Don't worry about that one that it makes. Just look at the one that you started with. And so the one that I started with, I'm going to need to find out what the outer radius is and what the inner radius is. So maybe let's just start with that. Outer radius. So the outer radius is from the axis out. If you look, this whole length here is 5, and that never changes. This length here is x. So what does my outer radius equal? My outer radius equals 5 minus x. The way you could always check this is you could plug in an x value. If you plugged in x equals 0, you'd see, hey, my radius equals 5. If you plugged in x equals 2, you could check and say, well, if it's x equals 2, my radius would be 3. And so you can always check your setup to make sure you're doing it right. So my outer radius equals 5 minus x. My inner radius, well, let's look at my inner radius. This is actually kind of fun. My inner radius just goes from 5 to 2, and since it's a straight line here, it's always going to be 3. You could have written it as 5 minus 2 if you really wanted to. Then you would start to see themes here, right? 5 minus x and 5 minus 2. So my integral is from, well, let's do radius squared minus inner radius squared, and it's a dy. Okay? So I need to write everything in terms of y. So that's my first thing. But now I'm just going to start by plugging in, right? Radius squared minus radius squared dy. Now, the easy one is my small radius, 3. Just plug it in. Okay? My outer radius is 5 minus x, but I can't write x, remember, because I have dy, so my x is equal to square root of y. Just in case you forgot, y equaled x squared, so x equals square root of y. Okay? Now, my terms, upper and lower bound, I go from 0 and I go up to 4. Because my slices are horizontal, and I'm adding them up from 0 up to 4. Now, right? And then you would have to actually do this. distribute it out, solve it out. The other option is if you use your calculator, you could plug this into y equals, and you could hit second calc and go from there, where you could find the integral of it. If you need help with doing that, let me know and I'll help you on that. So let's do our last one, where it's about y equals 6. So here is my area, and it goes up to 4, and we're going to rotate it around y equals 6. So this is fun to draw. What I would like you to do is I would like you to try to set it up. What's the outer radius? What's the inner radius? Okay. All right, here we go. Welcome back. If you didn't pause, shame on you. Okay, so sorry, had to. So outer radius, inner radius. So right, and this thing's swinging around in a circle. And so you're getting this big kind of donut shape. So I'm going to have an outer radius, and I'm going to have an inner radius. Well, let's start with that idea. Let's just find those. So my outer radius, well, I'm going from 6 to 0 all the way across. So it's going to be 6 minus 0 is my outer radius. Well, let's look at my inner radius. My inner radius is 6 minus, the y. Because if you think about it, the height of this is going to change, but the height of that box, the height of that blue box is always y. So this inner radius here is going to equal the total distance 6 minus that y, and that's going to give us that last piece. Now, I think you have caught on, hopefully, that this is a dx idea, because this guy is faced vertically, so it has a width of it that's x. And so my integral is going to be in terms of x's. So from 0 to 2 of outer radius squared minus inner radius squared dx, meaning I can't have y here. So I'm going to have to rewrite that. So integral from 0 to 2 of outer radius squared, 6 minus 0, minus inner radius squared, 6 minus, I can't write y, but y equals x squared. Plug it in, and you got it. So I've got pi times the integral of 0 to 2 of 6 squared minus 6 minus x squared squared dx. This is doable by hand. You have to FOIL that out first, and then off you go. You are going to have issues with that negative sign. You got to be really careful and be consistent. So quick review, just to think about what we did. Take a second, and what I would do if I were you is I would go back and I would try these problems again, maybe in a day, and can you do them without seeing the work, and then use the work to check. Go back, try more problems, make sure you're doing odd problems, make sure you're working through stuff. Alright guys, thanks for tuning in. Have a great night.